All right, folks. In a previous video, we worked through the screening for our paired sample test that we did in class. This time working through the problem in Stata. What we're going to do here, work through the actual paired sample test, calculating confidence intervals, the actual inference test, and then auxiliary effect sizes, auxiliary statistics here within Stata. So the worksheet or the handout that we're going to be working with is the paired sample T, going through and providing output in our stuff here. The example that we're working with, again, remember that what we're doing is we're running a pilot study on manipulation check for an anger induction and a positive imagery laboratory manipulation. For the first, we're getting ratings of 0 to 10 anger at baseline, and again following a 2-minute anger induction period where participants are asked to imagine a time when they experienced intense feelings of anger. And what we're wanting to see is whether or not this manipulation was effective based on increases in 0 to 10 anger ratings from baseline to peak level of anger during the manipulation. And then also what we're going to do once we did that, we then instructed participants to, instead of thinking about an angry memory, thinking about a memory in which they experience intense positive emotions. For a period of 2 minutes, every 20 seconds, they rated again 0 to 10 anger ratings. And what we would want to do for this anger or this positive imagery manipulation, want to see if we get evidence of reductions in anger from the initial anger rating at the start of the positive induction to the final anger rating. So for the anger induction manipulation, wanting to see increases in anger when they're thinking about an angry memory, and for the anger recovery, the positive imagery period, hoping to see reductions in subjective anger. Okay, so we'd gone through and we had screened, and remember that we had found one case with a missing value, but aside from that, everything looked good. All of our values were within reasonable limits. Our distributions looked okay. Our histograms and our box plots looked all right. We didn't find any evidence of extreme values in terms of the different scores, which are ultimately what we end up looking at in terms of our paired sample tests. And so based on that, we're ready to go through and actually run our paired sample t-tests. Now, paired sample tests in Stata, pretty easy. T-test, anger peak equals anger start. Okay, so these are just basically saying the syntax language here is saying basically a statement of the null hypothesis that anger ratings at the peak level of anger will be equal to anger ratings at baseline or at the start. Same thing, t-test for the positive imagery, sub-anger 6, this is going to be my final anger rating during the positive imagery, is equal to the first level, or the first rating that we made here. So again, pretty simple and straightforward. So what I'm going to do is I'm going to start by running my test for the anger manipulation, run this, and we get, here we see our t-test, our paired sample test. We have the number of observations to start, mean, standard error, standard deviation, 95% confidence interval around anger ratings at peak. Here, the number of observations, mean, standard deviation, and 95% confidence interval around anger ratings at baseline. And then what we have here, what we're really interested in terms of the crux of things with this test, is the mean difference between peak anger and baseline anger here. Here we're seeing our standard deviation and then our 95% confidence interval. So based on the data that we have, our best guess for the difference in, or the increase in anger for the population of individuals completing this manipulation is going to be an increase of about 4.5 points. on that 0 to 10 anger rating scale, which is pretty good based on the data that we've collected, though any values from 3.8 to about a 5.1 unit increase in anger scores would be consistent with the data that we've got. Okay, so again, looking at our confidence interval, this is looking pretty good in terms of success of our manipulation. We're seeing about a half a scale. Again, if this is 0 to 10, well, not quite, but close to a half a scale increases in terms of ratings of subjective anger, with a high end of about 5 points, a low end about 3.8, close to 4-point increase, and so this is looking pretty good in terms of the efficacy of my anger manipulation. Okay, if I go down through and I take a look at my inference test, here my t-test 13.6 or 13.7, that's a huge test statistic with 41 degrees of freedom. And for my two-tailed test, I see that I've got a p-value less than 0.0001. Okay, so what I might want to do now, so I've got my confidence interval says that even at the low end, right, even if the lower limit of my confidence interval, a 3.8 unit increase in anger is still sort of noticeable and I would say pretty reasonable. High end about over 5 points. But what we might want to do, because this is a 0 to 10 scale, I might want to go through and take a look and see what the mean or what a standardized difference might be. Okay, so now remember, when we're talking about our effect sizes for our paired sample tests, just like our independent samples, we have some different options. Okay, so what we could do is we could calculate an effect size based on the mean of the difference, or the difference in the mean scores, over an average variance estimate, the square root of an average variance estimate. So this is basically like our sort of equivalent to our hedges G. Or we can calculate a Glass's delta. Glass's delta, again, is going to be the mean of the difference scores, or the difference in the two means, over a standard deviation at baseline. And Glass's delta is nice because it gives us, if we have kind of a starting point, it gives us a nice option to say, okay, well, relative to standard deviation or variability at baseline or at control, what are we seeing in terms of change? So for this study, because we've got a manipulation here where we do have a baseline, I think what I'm going to do is I'm going to calculate Glass's delta here. Okay, so if I go up and I'm saying, okay, here's the mean of the difference scores, okay, or the mean of, or the difference in these two, right? So this is telling me the increase from baseline to peak anger. What I can do is take this and divide it by the standard deviation at baseline. Okay, this is peak, and this is anger at start. Okay, so again, what I'm going to do here, take the mean of the difference over standard deviation at baseline. So again, in Stata, I can just hit display. Calculate that, divided by my difference here. Wow. Okay. So essentially, I've got a Glass's delta of, say, 2.11. Functionally, what this is saying is, relative to variability at baseline, we're seeing approximately over a 2 standard deviation increase in anger scores as a result of this manipulation. That's really, really big. Okay, so if we wanted to go through, calculate supplementary statistics, again, our S values and our base factor bound. If remember from class or the previous two videos on single sample T and independent sample T, hard to calculate because we actually didn't get a value here. It's really small, but what we can do with our calculator is we can just have Excel calculate the exact p-value within the guts of the program based on our test statistic and our degrees of freedom. Okay, and so we're getting an S value here of 54. Right, so basically the data, these data against these data are providing similar evidence against the null hypotheses as would be getting 54 heads in a row in flips of what I told you was a fair coin. Seems pretty implausible that that coin's fair if you got 54 flips in a row. Bayes factor bound is massive, 1.39 times 10 to the 14th. That's huge, right? So we have very, very clear evidence in support of the effectiveness of our of our manipulation, and then sort of most importantly, looking at our confidence interval here, seeing that even the lower bound estimate that would be compatible with the data that we've collected is still suggesting close to a 4-point increase in subjective anger as a result of this anger imagery manipulation. So we're pretty pleased with this. Okay, so that was the first question we had, but then we also wanted to see, when we asked people to imagine a time when they felt intense positive experiences, can we correct this? Can we get people to demonstrate reductions in anger, subjective anger, during the positive imagery, right? So what we're going to do is we're going to run a paired sample test where we're saying that subjective anger at the final rating during the positive imagery is equal to the initial anger rating. Go through and run this, and Stata is going to give us our paired sample test. Again, this is going to give us descriptives for anger ratings at the final rating of the positive imagery manipulation, anger ratings at the initial time point here. Okay, and then again here what we're interested in is our difference. So we're seeing, based on our descriptives here, we're seeing on average in this sample a little over a 1.5 point increase in, 1.5 point decrease in ratings of subjective anger from the final anger rating to the first anger rating over the course of this 2-minute positive imagery manipulation. Standard deviation of about 2.2. And then here's our 95% confidence interval. Okay, so based on these data, it looks like estimates of the population reduction in individuals completing this manipulation, values ranging from about a 2.3 point reduction anywhere to about a 1 point reduction is going to be consistent with the data that we've obtained here. Okay, so we've got a smaller effect than for the anger imagery, but still what we're seeing is some evidence for reductions of anger when people start thinking about positive emotional experiences. Again, our best guess is a little over a 1.5 point reduction in subjective anger in response to positive imagery, with limits going from about a 1 point reduction to a little over a 2 point reduction here. Okay. Now, if we go through and we take a look at our test statistic, we've got a T of 4.87. That's pretty big. Degrees of freedom here. And again, if we look at our p-value that we get off of our paired sample test, it's still less than 0.0001. So we're still seeing evidence for reductions in subjective anger following positive emotional imagery, but not quite as much as what we would have in the initial, or what we did in the initial anger induction. Okay, so wanted to calculate an effect size for this. So I could calculate Glass's delta. That would be easy. If I wanted to say that anger at the initial time point is a good baseline, so I could do that. Again, if I hit display my mean anger reduction divided by, let's say, anger at the initial baseline. If I wanted to do that, give me a Glass's delta of negative 0.64, which is about that moderate size effect. Okay, so again, we're seeing reductions, but not nearly as much as the reductions that we saw. Correction, calculated Glass's delta. I used standard deviation of the different scores. What I should have done here is this should be mean difference divided by standard deviation at baseline at initial, not standard deviation of the different scores. Whoops. So if I go through and I do that, so my glasses delta for my anger induction is actually larger than it was here. This is standard deviation, looking at standard deviation, using standard deviation of different scores. We talked about that up here. There are times when we'll want to use this, particularly if we're calculating confidence interval around that. But just to clarify, here in the initial one, we didn't actually get a glasses delta. We used the wrong standard deviation. So, but if we go through and we divide the difference from peak to baseline and divide that by baseline level standard deviation, what we get is a test statistic of, or an effect size of 2.67. So it's actually bigger than what we had expected. Okay. Now glasses delta for, we did calculate this one correctly, for anger recovery, about 0.64. That's still a decent sized effect, about within that medium range. The other thing that we could do is we could calculate the standard Cohen's d using the average, the square root of the average of the variance as a standardizer. Now, we'll see if we can do this in Stata. We can. I just don't know if I'll do it correctly here. But if I want to do that, divided by, let's say, SQR square root of this standard deviation, squared, because I know the variance, plus that standard deviation, square that. Okay, so that gives me this plus this divided by 2. I think that should do it. Yep. Okay, cool. So you could do this by hand on pencil and paper, just showing you that you can go through and pull this up in Stata as well. So basically what we've got is the mean of the different scores divided by the average, the square root of the average of my variances, right? So this is my standard deviation at my final assessment point, standard deviation at my initial assessment point. I'm squaring both of those to get my variance estimates, and then I'm adding those variance estimates, dividing them by 2, gives me an average, and then I'm taking the square root of this, which is going to give me the standard deviation of my average variance. So hadn't planned on doing that in Stata here, but showing you that you can just use this as a calculator to go through and do it. So we've got a really nice, solid effect size here. If I wanted to go through, calculate S values and base factor bound, again, grabbing my test statistic here, plugging it in, degrees of freedom, 41. Drop that in there. So my S value for my anger recovery is going to be 16, which is still pretty good. Bayes factor bound, which is still really large, right? So we've got clear evidence here against the null hypotheses, suggesting no change in subjective anger. Now, the changes that we've got in the anger or the positive imagery reductions, not as great as the increases in anger in response to anger imagery, but still some evidence here. If we can think about something happy, resulting in at least some reductions in, at the low end, at least 1 point reduction in subjective anger, I guess we can say that's not too bad. Okay, so if we want to go through and take a look at our write-up, again, for something that you might write up in for a problem set here, looking at your screening here, working through, we've got strong evidence against models specifying zero difference in ratings of subjective anger during negative and positive imagery. Here we're just listing out all of our test statistics. We say the 4.5 unit increase in subjective anger following negative imagery task, consistent with a 2 2/3 standard deviation increase in ratings relative to baseline. Again, that's actually incorrect. That's not delta, that's D average, so we need to fix that. Data are compatible with increases in anger ranging from 3.8 to 5.1. Here's our confidence interval. We'd say that the lower bound estimate provided by the interval continues to suggest over a 2 standard deviation increase in ratings relative to baseline. Recovery was more modest, but consistent with conventional benchmarks for medium effect. 95% confidence interval indicated reductions of negative 0.96 to 2.32. Again, providing clear and observable evidence of clear and observable change in anger following both manipulations, although it looks like anger imagery appears to have a stronger influence on experience than positive imagery. Okay, so again, that might be something we might write up for class, for publication, grading both of those, kind of condensing this down, but again, giving you examples for language you might use to describe some of this. Okay, so that walks through everything. Had a couple of hiccups there, but made it through. That should hopefully give you a good idea for what things should be looking like in terms of Stata.